So we're going to now look at the third issue, which is dealing with mutually exclusive projects. And there's two components to this. So the first one is size. Whenever we have mutually exclusive projects, remember that we only have one of several potential projects to choose from. So this is the dependency. Accepting one project will affect the decision of another project. And the reason why IRR doesn't work here is because of scale issues or size issues. The IRR ignores the magnitude of the project. So because you can only choose one project, a higher return does not necessarily mean that this would be beneficial for you. So here's an example. You own a piece of land, you can only build one type of business, but you can not do both. So choose a factory, choose a shopping center. So the problem we have is that you might prefer the IRR of the factory might be much higher than the IRR of the shopping center, but the magnitude of the shopping center might be much bigger than the factory. So here's an example. Would you prefer if I offered you an investment, a $10 investment that offered you a 100% return, or a $10,000 investment that offered you a 10% return? So although the 10% return is lower on a percentage basis, given the amount you could invest in, it would be much better to take that second investment. And that's what IRR is missing. It's not taking into account the size. So we can actually salvage the IRR here by basically using what we call the incremental IRR. We will I'll provide a PDF for the exact algorithm, but basically what we do is we look at the smaller project first. We decide, is it acceptable or not? If it's acceptable, we then look at the additional amount of money you'll have to invest in to take on the larger project and see if that incremental investment is worthwhile or not, and then choose the project that way. I'll go through an example, and then we'll come back and look at the this second part of mutually exclusive, which is timing issues. All right, so we're going to do a couple things here. We're going to compute the IRR for each project. We're going to compute the NPV, and then I'm going to walk you through the incremental IRR. So let's start with IRR and NPV. So what I'm going to do is I'm going to do the IRR, I'm going to do the NPV. I also want to plug in here, we'll do it up here, the rate, which is going to be 10%. So I want to be able to reference that for this problem. All right, and so we can start with IRR. It's a simple problem because it's only two cash flows. So the IRR for project A is 100%, the IRR for project B is 75%. These are great projects. Our required rate of return is 10%. Let me label that as required rate for you. And we'll wrap that. All right. So when you're looking at this particular project, you would say, oh, this is a really nice project. Now, the question is, we can only choose one, right? They're mutually exclusive. So if we were to compute the NPV, and in this case, I think, the NPV is the 10%, and then we'll take that value and add that. So the NPV for A is 8,181, and for B, it's 11,818. So even though B has a lower IRR, it has a higher NPV. So in some sense, we would prefer project B based on NPV, but based on IRR, we would prefer project A, and that there shows you the issue with the when we're dealing with mutually exclusive. So what I'm going to do is I'm going to now compute the incremental cash flows. Incremental cash flow, and so I'm going to basically, let me make it look nice. Okay, so we're going to basically take the smaller project based on the initial investment. We're going to subtract that out from the bigger project. So we're going to take B minus A. So if I invested an additional 10,000, I would earn an additional 1,500. So basically, I can look at the way I look at this. I say, okay, project A, good, IRR is 100%. Now, if I take another 10 grand, and I could get to project B, And if I take another 10,000, I would get another 15,000 in time one. Is that worthwhile? And so basically, I'm just going to take the IRR of these incremental cash flows, so you can see just how the labeling goes. And you can see it's 50%. 50% is above 10%. So based on the incremental IRR, that's what this is. I'll highlight that and I'll label that as incremental IRR, IRR. Based on the incremental IRR, I would prefer the bigger of the two projects. In this case, project B, I would prefer the bigger project, project B, because that is going to, that additional investment, that additional 10,000 is worthwhile. Now notice, this matches up exactly to the NPV. And so that's how we can use the incremental IRR when we're dealing with mutually exclusive projects. So the other issue here is the timing of cash flows. The timing of cash flows matters a lot. And the question that you need to ask yourself is, do you get more earlier or later? If you notice here in this example, if I were to pick project B, project B is receiving more overall if I just add it all up. Right, so if you just take, they both start with minus 10,000, so if I just add up the future cash flows, project B has 14,000, whereas project A only has 12,000. The issue with project B is that cash flows are coming later on. For lower discount rates, more is better. So if the discount rate is going to be lower, then I actually prefer project B, and you can see that here with the on this plot where I'm plotting the NPV over the time. So for example, if I'm looking at the red line, project B, for lower discount rates it's better, but then it switches. So at some point, as the discount rates get higher, I'm better off getting, although less money overall, more of it earlier on. And so that's an issue that the IRR can't distinguish. Again, we can solve this a little bit by looking at the crossover rate. And in this case, if we look at the crossover rate, what we're basically doing is we're taking the difference, just like the incremental IRR. The only difference now is that they both start at the same amount. So what we're basically doing here is determining where is it going to cross. And so we can find that it crosses at 10.55%. That would be if we, finding the IRR of A minus B or of B minus A, does not matter. And what we can then say is, for those discount rates below 10.55, we would prefer project B. For those above 10.55, we would prefer project A. And it's going to, again, depend on the timing of the cash flows. This example is fairly simple. It could be more difficult, and you still might need to rely on NPV to help you make those decisions. Final piece of the IRR is one of scale. And we sort of talked about this a little bit, but if you look at this particular scenario, project A and project B both have the exact same NPV, $1,400. The problem is that the IRR for project B is 8.01, and the IRR for project A is 15.58. Now, when I say NPV at 8%, that 8% is sort of the required rate of return. It's not entirely random, but it's not exact. This 8% is not an exact science. And so the question you need to ask yourself is, are you willing to invest $9 million to earn to add $1,400 of value, knowing that if you're off by just 0.02%, right? If instead of 8.01 it became 7.99, it would become a negative NPV project. Are you willing to do that? And what the IRR here tells you is that you have a lot more wiggle room for project A. So in other words, as long as the required return is below 15.58, so even if 8% should be 9%, you're fine. You would be okay with project A. So I think this is the key thing. Now again, this I think also helps to answer part of the question, why is the IRR used so much? Because it really can serve as a bit of a check on the NPV. And so that's something that is again, if you add up those percentages of use, they're used multiple times. They're used so they add up to more than 100%. So most of these things are used more than they're not using only one for these different projects. So in summary, the benefits of the IRR: easy to talk about rates of return rather than dollar values. The IRR is only needs to estimate the project cash flows if the return is high enough. The disadvantages: non-conventional cash flows in mutually exclusive projects cause issues, and you need to be able to identify those problems.